Hi everyone, in this video I'm going through Chapter 8 from the CCNA Routing and Switching Study Guide written by Todd Lamel. Chapter 8 primarily focuses on kind of an intro to routing protocols, beginning with RIP. So there are a few hands-on labs at the end, and that's what I'm going to be working on here. So to begin, we're going to start setting up a simple network with a few routers and a couple of end devices. We could add another one for this router, but we're not really going to be using it, so it's not necessary. As with most of these, we need to shut the routers down individually and add some serial interfaces. So we're going to do that to begin. Okay. Next, we're going to start cabling, and we'll work on configurations and host names in a minute. So between our routers, we want serial cables. And then from computer to router, we need to use crossover cables. And this is simply because we're using Packet Tracer. In a real live environment running Windows 7 or newer, you don't really need a crossover cable. Straight through would be fine. Alright, so we have our kind of simple local network with a little bit of routing going on, maybe between branches or between buildings, whatever the case may be here. We have a network scheme already planned for us, so we'll use that to begin. And so the first thing that we're going to do is a host name. And so this is going to be lab A. And then we'll need to configure some IP addressing. In the book, if you're following along, they're using fast Ethernet interfaces. I'm using gigabit interfaces, simply because that's what my routers have. And their network scheme is all /24 networks, even their serial interfaces. So we get both of those set up. I'm going to go ahead and give a clock rate. They don't mention it, but I like to do it just to stay in the habit. And then one more thing we'll need to do for the gigabit interface is bring it online. Alright, so we need to go and configure the other two routers as well. So, following a very similar scheme for the IP addressing, serial interface will be up by default, so we don't need to give the no shut command here. And our last router, alright, and give the no shut command to bring it online. And the next thing that we want to do, I'm going to go ahead quickly and change these display names to match the device host name. Alright. And then we're going to go ahead and do the PCs really quickly. We're going to need static addresses since we don't have any DHCP set up. So lab A is 172.16.10.1. So I'll make the computer 10.10. Make sure that it gets the gateway address. And we'll do the same thing with the PC on this end. And this interface on the lab C router is 172.16.40.1. So I'll make it 40.10 for the PC. And make sure we assign the gateway. Alright, at the very least we should be able to ping our directly connected routers. Might need to take a look at that. Should be up. So they were all shut down by default. So we'll bring them all online. There we go. Fast forward time, let them get connected, and then we should see some successful pings for the directly connected devices. Alright, so we haven't done any kind of routing yet, so we don't have any kind of remote pinging working yet. And so that's what we're going to begin. Now that we have our network built, we're ready to begin the hands-on lab 8.1, creating static routes. So part of this lab was configuring the IP addressing. We've already done that, and we're ready to begin creating static routes. So we're going to start with lab A. I'm going to come back to the global configuration mode, and we're going to give the command IP route 30.0 first. So remember, we don't need to include the directly connected networks. So we have 172.16.10 here. We don't need to include that, and then 16.20 is here, so we don't need to include that. 16.30 is a remote network, and 16.40 is a remote network. So we'll need 30 and 40 both. So we give the command IP route the network address of the remote network, the subnet mask of the remote network, and then the exit interface, either by IP or by interface type and number. Or rather, the next hop, not the exit interface. Exit interface is later. So the next hop address, which is this interface on the lab B router. So we'll do the same thing for the .40 network. And then we want to go ahead and save the configuration. And we're ready to move on to the lab B router. And so the lab B router has two directly connected networks. If it had a LAN, it would have a third network right here. I'm going to go ahead and skip that because we've already got two directly connected PC environment networks. So he really will just need to know about these PC networks. So again, back to the global configuration mode, and just build the static route. So to the first PC network over here, and then the next hop address, which is the serial interface on lab A. Sorry, 20.1 serial interface. And then we'll do the same thing for the other PC environment. Which is the 16.40. And this one we will be going through 30.2. which we configured as the serial interface on lab C router. And then we'll do the same thing here. Save the running configuration. And then we will configure the lab C router. So he knows about these two directly connected networks. We'll just need to give him .10 and .20. And then the next hop which is going to be the lab B serial interface here, 30.1. And we'll also need to give him .20. Okay, then we'll do an exit and save the running configuration. Alright, and now we should be able to verify that we have all of our networks. So that was lab A, this is lab B, and lab C. And just to review these really quickly, we have created these two static addresses, .10 and .20 from lab C router through that next hop address. Directly connected is the .30, which is the link to the lab B router. And then it's automatically detecting the local as a /32. This one is the directly connected LAN for like our PCs, and again, it'll pick up that /32 local. Alright, so we should be able to ping go to the gateway first. So we just went from here to here. Next, we'll go and make sure that routing is working through here. So we're going to go to 30.1. Okay, and that shows that we're making it through lab C router over to lab B router. Then we'll go to 20.1, which is bringing us all the way across to lab A's serial interface. Then we can do 10.1, which would get us to this interface on the lab A router. And then 10.10 should get us over to PC0. So that way we can see that our static routes are working properly to connect all the way across. Alright, so that completes lab 8.1. Now for lab 8.2, we're going to configure RIP routing. So this will be dynamic rather than static. The downside of static is that if a link goes down, it can't automatically try to find a new route. It does have less overhead, less impact on the network because nothing's being broadcasted for the routes. A little bit more security there because it makes it harder for anybody to intercept your routing tables. But again, if something goes down, it's down until you go manually fix it. So an alternative to the static routes is dynamic, beginning with the simplest, which is RIP. So we're going to begin on lab A, and the first thing we're going to do is remove our static address, our static routes. So again, we only put in these two, .30 and .40, so we'll need to remove both of them. Depending on whether you're doing this on physical hardware or Cisco Packet Tracer, I think Packet Tracer needs the subnet mask, but it does not need the next hop. If you're doing physical hardware, depending on the iOS version on your Cisco hardware, you may need to include the next hop address to remove the route. But you can see in Packet Tracer you don't need to do that. So we'll strip both of those routes out. And then we should see the only routes are directly connected now. So we don't have any remote networks. So we need to do the same thing for the other two routers. Leaving us with only directly connected here. And we'll do the same thing on Lab C. So we have our directly connected networks. Alright, and that will bring all of our routing to a screeching halt. So now we're going to go ahead and work on configuring our IP. So again, we'll start in our Lab A router. And it's fairly simple to get it started. It's just router RIP. And there are a few things you can do in here. I generally recommend bringing it to version 2. I think for this lab it won't really be necessary because everything's going to fall on one network, one summary network, pretty nicely. So I'm going to skip that. The other that I usually recommend is a no auto summary command. This will prevent the router from automatically summarizing your routes for you. Again, I don't think it's necessary for this because everything is going to fall into one nice summary route regardless. So it has, because Lab A router has two interfaces, and each interface is in a separate network, the .10 and the .20. We have to have a network statement that utilizes the network ID that encompasses both of those. The alternative would be to have one for each. So we could do that and then come back and add the .20, but it's a lot easier just to combine them both into a quick summary route. And like that, it's that easy. So we're going to go do this exact same thing on the other two routers. Give it a moment to make sure it has everything connected and updated. And then we'll go ahead and start in router for Lab A. And we're going to give the command show IP protocols. Well, I need to come out. Show IP protocols. And we can see that it has RIP configured, RIP, sending updates every 30 seconds. Hold time is, looks like 180. So it's updating across the network every 30 seconds. So you can see that already is starting to add some overhead to your network. We see that network that we informed it of, which is the large summary for everything here. We see also the default administrative distance is 120. That can be configured to help you optimize your routes. So the next thing we're going to do is a show IP route. And we'll see that it has 10 and 20 directly connected, which we know, and it is learning 30 and 40 from RIP from the other routers. And so that's a dynamic protocol for routing, because if it goes down, it can automatically try to build a new route to handle traffic routing to those networks. We can go ahead and do the same thing on the other two routers. We'll see that it's building. So lab B in the middle here should be dynamically getting .10 right here from RIP, and .40 also from RIP. We see that here. The rest are directly connected, and that's fine. The third router, the lab C router, is learning about 10 and 20 through RIP, both of these, and the rest are directly connected. 30 and 40 are directly connected. We can always issue a show run to see everything that's going on. And see that router RIP is enabled. Alright, so we've verified all of the configurations. Let's go ahead and we'll do copy run start, or copy running configuration to startup configuration, to save these. And then we'll attempt pinging again, and we should have success with those dynamically built routes. And that should be true across all devices now. Alright, it looks like that pretty much covers everything for the video. As always, if you have questions, comments, please feel free to leave them for me below. Thank you so much for watching, and I hope to see you in my next video.